Question number 19. Line segment EA is the perpendicular bisector of line segment ZT. So it's the perpendicular bisector of that. So then I've got that that is equal to that. And also, I have that it's perpendicular, so I have right angles. Also, ZE and TE are drawn. Well, what I should notice right here is that because I have a perpendicular bisector, I've got it perpendicular, those two are equal. By the reflexive property, I can say EA is equal to itself, which is just obvious. And now I've got side, angle, side, which means that these two triangles are congruent to each other. And that also means that all the corresponding parts are congruent. That's CPCTC. C, corresponding parts of congruent triangles are always congruent. So that means that these hypotenuses are equal to each other, that angle Z corresponds to T, so angle Z and T are equal, and that means that angle AET is congruent to angle AEZ. And so now I have all that. Let's see. I haven't even looked at the question yet. I've just drawn in what they gave us and decided, wow, I mean, this is just an obvious thing that comes out of this. Which conclusion cannot be proven? That EA bisects angles ZET. Well, from the picture that we just drew, I see that this angle is equal to that angle, which means that ZET, the whole thing that was up before it, the whole thing got cut into two equal parts, so that means EA did bisect ZET. That's not my answer. Triangle EZT. EZT, the whole big triangle is equilateral. Well, I know it's at least isosceles. I don't know if ZT is necessarily equal to EZ or ET, so maybe that can't be proven. Maybe it can be. EA is the median of triangle EZT. A median, not the median. A median is a line where you take some point on some vertex and you draw to the midpoint of the opposite side. Well, since it's a bisector, since EA is a bisector, that means it hits the midpoint of ZT. So if it hits the midpoint and is coming from the vertex, it is a median. So 3, that can be proven, which means it's not my answer because I want what cannot be proven. Angle Z is equal to angle T. We had our side angle side and CPCTC solve that for us. So that can be proven. We already proved it. That's not my answer. It looks like number 2 is my answer. EZT is equilateral. I can't necessarily prove that. And if you want, I'll give you a little drawing. Here's an example of a perpendicular bisector and two lines drawn, where it becomes pretty clear that even if that little line there is a perpendicular bisector, that this is not an equilateral triangle over here. Even if this is a perpendicular bisector, obviously it's not equilateral, so this cannot necessarily be proven. I just showed a counterexample. Answer is 2. Question 19. June 2016 Regents.